reactivity mean? Well, reactivity means that something reacts. So reactivity is basically describing how reactive something is. So if something is reactive, then the reaction happens very easily. So let's imagine that So let's say we put some metal in some water and we get a couple of bubbles coming off it. We can say, okay, it's reacting, so it's a little bit reactive. If we put some other metal in the water and it makes a lot of bubbles, then we can say that metal is more reactive. So how strong and crazy the reaction is a measure of how reactive it is. Okay, that's basically what reactivity means. And now some metals are more reactive than other metals, and that's related to the electrons. And the reason why it's related to the electrons is because when things react, especially when metals react, they lose electrons. So that's what it says here. Describe how the reactivity of metals are linked to their ability to lose electrons. So whenever a metal reacts, it loses electrons. And some metals are better at losing electrons than others, or they can lose electrons more easily than others. And so let's say, imagine we've got, in fact, we'll start off with lithium. So lithium has got atomic number of 2, which means it's got, atomic number of 3, and so it's got 3 protons, which means it has 3 electrons. So if I draw lithium, we're not interested in its nucleus right now. We're just going to draw its electrons. So there's the first 2 electrons, and the first shell can only hold 2 electrons. So when we put the second shell on, we put that one there, and lithium, all atoms, they like to have a full outer shell. So when I want to make this, when I react in this lithium, I'm going to just remove that 1 electron. It's a lot easier to remove 1 electron than it is to remove 2 electrons or 3 electrons. And so lithium is quite reactive because it only needs to lose 1 electron. Now, if we look at the next atom, the next element in the same group, if you want to just look at your periodic table and find lithium, which is in group 1, and can you tell me the element underneath lithium? So if you go to a periodic table, then you can see lithium has got atomic number of 3, sodium's got an atomic number of 11, so that's the next one. So let's draw sodium next then. So sodium, again, we're only interested in the electrons, so let's just draw the symbol in the middle rather than the nucleus. And it had an atomic number of 11, so it's got 11 electrons as well. The atomic number actually tells the number of protons, but neutral atoms would have the same number of protons as electrons. And so if it's got 11 electrons, it's got 11. If it's got 11 protons, it's got 11 electrons. So I tend to draw, the next shell can hold up to 8, and I tend to draw them in pairs because you can see them more easily. So that's 6, and then the other 2, that makes it 8 total. So we've got another 2 to do there. That's up to 10. We still need to add 1 more, and so we need another shell. And just like lithium, it's also got 1 electron in the outer shell. So sodium and lithium both have 1 electron in the outer shell. So it's quite easy to remove the electron from lithium and from sodium, and so they're both very reactive. But sodium is even more reactive than lithium. So why is sodium, even though they both only have 1 electron to remove, why is sodium more reactive? Well, the reason is because this electron is further away from the nucleus. And when it's further away from the nucleus, it's easier to remove because the nucleus is trying to pull it in, but if the nucleus is further away, then it's not going to be able to pull it in with much force. So that's the reason why. Basically, that's all you really need to know about this bit here. Describe how the reactivity of metals are linked to their ability to lose electrons. When things react, when metals react, they're losing electrons, and if they only got a small number of electrons in the outer shell, then it's easier to lose lose them than if they had more. So they're just trying to clear that outside shell. And if it's got lots of shells, then it's easier to clear the outer shell as well. So they become even more reactive. So the lowest one in group 1 will also only have 1 electron to remove, and that's francium right at the very bottom, and that's got many, many shells, and it's still only got 1 electron to remove, so it's extremely reactive, and it's in fact the most reactive metal on the periodic table. So we'll leave that video there.